shear force and bending moments. We are given a simply supported beam in figure 3, and it's loaded with a uniformly distributed load of 5 kN per meter between point B and C. It also carries a point load of 25 kN at point B and a point load of 20 kN at point C. The first question says, draw the fully dimensioned shear force and bending moment diagram of the beam. To do this, you will have to find your reactions first, your RA and your RT. Then the second question says, find the point of the maximum shear force and the shear force and bending moment of the beam. Now, let's start with the question. Okay, so now the first thing you're going to do is draw your free body diagram. So we have our beam, and we have a reaction here at A, and another reaction at D. So RT, this is our RA. For a pin support, we have a vertical and a horizontal reaction. So RAH, RAV, and then we have the UDL. You have the 20. You have the 25 and the 5 kN per meter. Now let's start with our reactions. To find our reaction at A, we're going to take moments at D. And then to find our reaction at D, we're going to take moments at A. And then use sum of forces up is equals to sum of forces down to check if our answers are correct. Let's start with our reaction at A. So we're going to take sum of moments at D, clockwise positive, is equals to 0. You have the 20 going anti-clockwise, so you have minus 20 times 2. You have the 5, it's also anti-clockwise, it's minus 5 times 2, 2 over 2 plus 2, which is the remaining distance to come to here from the center to the point of our moment, minus 25 times 2 plus 2. And then our reaction at AV, our RAV is going clockwise. Then we have our RAV times 5. That that's equals to 0. Minus 20 times 2 minus 5 times 2, 1 plus 2, which is 3, minus 25 times 4. So we have minus 170 plus 5 RAV is equal to 0, and then our RAV will be 170 divided by 5, 634 kilonewton. Now let's take moments at A. Sum of moments at A, clockwise positive, is equals to 0. We have our 20, which is positive. 25, 25 times 1 plus our 5 times 2, 2 over 2 plus 1, minus 20, 2 plus 1, plus 20. It's going clockwise also. Minus RT times 5. Our RT is going up, so it's going anti-clockwise towards A. We have 25 times 1 plus 5 times 2 times 2 plus 20 times 3, which is 105, minus RT times 5 is equals to 0. Then our RT is equals to minus 105 divided by minus 5, which is 21 kilonewton. And then for our checks, we're going to take sum of forces up positive will be 0. So up to 21 plus 34 minus 25 minus 20 minus 5 times 2. That is to give you 0. Which it does, meaning your reactions are correct. Our RT is 21. Our RAV is 34. You can take sum of forces horizontal is 0. And then we have our RAH is equals to 0, since we don't have any other horizontal force. Sometimes they might give you a point load. Let's use this one. Sometimes they might give you a point load at an angle. So it's a 20, and you're given 45 degrees. In this case, you're going to, when you break it down, let's use breaking. When you break it down, you're going to have a vertical of the 20 and a horizontal of the 20. And then in that case, our RAV won't be 0. It's going to be equal to the opposite direction of this one. Now let's do our shear force and bending moment. Let's put this, let's put it that side. Now let's do our shear force and bending moment. So we'll have the shear force diagram here, and up in the moment diagram, let's put it somewhere here. 0, 0, plus minus 0, plus minus. Okay, now let's do our shear force calculations. Draw a line. So we're going to have our A left, A right, B left, B right, C left, C right, D left, and our D right. Our A left is 0. Our A right is 34. Our B left is 34. Our B right is 34 minus 25, which is 9. You can put your kilonewton meter, you can put your units. Our C left is 9 minus 5 times 2, which is negative 1. Our C right will be minus 1 minus 20, which is minus 21 kilonewton. D left, we have minus 21 kilonewton. D right is minus 21 plus 21, which is 0 kilonewton. Now let's plot our shear force diagram. Let's use green. A right, A left with 0, A right we have 34. Let's put it here. We have 34. So it goes from here to there. B left is 34. It goes straight here, still at 34. Our B right is 9. Let's put it somewhere here. C left is negative 1. Negative 1, let's put it here. Our C right is 21. Somewhere here. And then our D left is still 21. And then back to 0. Now every time in your shear force diagram when you experience something like this, you have to create a new point. You have to create a new point at that point. Just a bit. Now let's do our bending moment diagrams. So let's call this new point B prime. And to find the distance from here to here, we have to, let me use yellow. I want to use similar triangles using this triangle and the small triangle. So for the big one, we have 9 plus 1, which is 10. The distance is 2. And then the small one, we have 9 with an x. So our 10 is 2, our 9 is x. You cross multiply, we have 9 times 2 divided by 10 is equals to x. It's 18 divided by 2. Sorry, 18 divided by 10, which is 1.8. The 1.8 is this side. This distance here will be 1.8. And then this one will be 0.2. Now let's start with our bending moment calculations. We have our A, B, B prime, C, and D. In bending moment, we use the areas of the shapes that we see here. Our A, we basically look at the left. We look at A left, B left, B prime left, C left, and D left. Our A left, 0. Our B left, we have a rectangle, which is 34 times 1. You get 34 kilonewton meter. B prime, you have 34 plus a triangle, which is 1 over 2 times 9 times 1.8. Then you get 42.1 kilonewton meter. Then I'll say left you have the 42.1 minus 1 over 2 times 1 times 0.2. And you get 42 kilonewton meter. The left you have the 42 minus 21 times 2, which is back to 0. Now let's plot our bending moment diagram. So we have 0 at A, we have 34. Let's put it here. You have 34. At D prime, you have 42.1. At C, you have 42. And then at D, back to 0. So this one is going to go straight to here. And then the UTL is going to curve. So it's curving. And then it's going to curve again here. And then it's going to go straight. You have 34 2.1, 42, and back to 0. And then we've answered question A. The B says find the position of the maximum shear force and bending moment of the beam. Now our max shear force, which is Vmax, will be 34. And then 34 at 0 from the left. 34 at 0 meters from the left. And then our maximum moment will be 42.1 at 2.8 meters from the left. And then that's how you answer shear force and bending moment questions. Sometimes you might be asked to find the point of contrafracture, and that happens when in your bending moment diagram you experience something like this. Say your shape is moving, and then let's say it curves in here, and then it curves back down like this. Yeah, let's say this was your shear force. You open the moment diagram. The point of contrafracture is going to occur at this point. This is the point of contrafracture. To find this point, you're going to take moments. You're going to catch your beam at this point, which will be somewhere here. You're going to catch your beam, and you'll either use this part of the beam or this part of the beam, and then you take moments at this point using the forces that side or the forces this side of the beam, and then you find your X. That's all for today.